Good afternoon, everyone. Very good afternoon, and welcome to today's Unit 1 class. I hope all of you are keeping fine, doing good. Guys, girls, all of you all, in our last class, we started the, Unit 1 exam paper corrections, but we didn't complete it. We have about 3 more questions to complete. Let's complete that, and then we'll move forward, okay? Everybody, can you take your papers? And then after that, guys, we'll be starting topic number 4. Okay, topic number 4, we'll have a few diagrams and, things for you all to draw. That's why I put a message on the group asking you all to have your stationery here. I hope everyone has it. I forgot to tell you all yesterday. Okay, right, boys, girls, everybody, can we come up to question number? Everyone over here, question 12. Surprisingly, many got it wrong. Okay, we have the OSI model, the Open Systems Interconnected Model, a theoretical framework. Okay, practically in the world, we follow the TCP/IP model, right, everyone? The OSI model is only used to explain the transferring of data. In reality, practically, what model is followed when transferring data? It's a TCP/IP model. Okay. Copy and complete the diagram to show the missing layers of the OSI model. So, guys, girls, when you look at this, when you're sending data, okay, from top to bottom, it is when you're sending data now. So, initially we have application, then we have, after application, we have our presentation layer. Okay, so application is where the data packets are going to be formed. Okay, data packets are going to be formed based on the application that's being used. So if it's a website, it will be HTTP, HTTPS. If it's uploading, downloading files, FTP. If it's email, XMTP. Then in presentation, 3 things happen, which are, in presentation, guys, 3 things happen, which are encryption, translation, and you want to reduce the file size before transmitting it, right? Compression. Okay, everybody. In presentation, 3 things happen: encrypting, translating, and compressing. Then what happens the next layer? You now need to ensure that the receiver is ready to receive data from you. So you need to initiate a session with the receiver, session layer. So over here, we only have one protocol, which is responsible for initiating the session, maintaining it, dealing with modifications, terminating it. Session initiation protocol. Then thereafter, guys, you choose your delivery method. In transport layer, what are your delivery methods? UDP if it's live streaming, UDP. VoIP if it's internet calls. TCP for almost everything else. For websites and all, for website emails, all that, we use TCP. Guaranteed delivery method, but not the TCP is guaranteed delivery, but not the fastest. Okay, UDP is faster, but then no guarantee in data delivery. You may lose certain data packets. Then, guys, after you choose your delivery method, it's time for you to choose the specific network that you want to send this data to. Okay, so this is defined in your, I literally told it to you all, your network layer. Okay, over here, your network layer comes into place. This deals with what? IP addressing, right? Network layer deals with IP addressing. What network is this data packet supposed to be sent to? Like what city do we send it to? Then after network, guys, you deal with specific devices. Which device is it supposed to go to? So what do we mention over here? Data link layer. Data link layer deals with MAC addressing. What is the MAC address of the device that these data packets are supposed to go to? Okay. And then finally, you have your physical layer, which is This layer defines the delivery method that would be used to transfer data across the network. Okay? It would choose between methods like TCP, UDP, or VoIP. There is also another answer, guys, in the marking scheme, which I have never mentioned to you all. Okay, can you guys read that marking scheme answer also? It is another answer that you guys can note down later on. Are you all done with this? Okay, so everybody read this method also. Because you need to understand, guys, your data is broken into so many packets, no? Your data is broken into so many packets, okay? And that data travels in different routes to its destination. Once it gets to its destination, it has to be reassembled and reorganized, isn't it? Your transport layer is responsible for that. Your transport layer is responsible for breaking. We don't say data packets, we say data segments. Your transport layer is responsible for breaking the data into segments and then reorganizing those segments at the destination. Are we all okay with this? It defines your delivery method. That's one thing, that's correct. Something else you can mention is, you might see this answer in some other marking schemes. Remember, it is also responsible for breaking your data into segments and then reorganizing, reassembling those segments at the destination. Okay, everybody? I'll tell you all one more thing. Okay, this OSI layer has so much of information to say. Okay, in transport layer, we don't say data packets, we say data segments. In network layer, we say data packets. In data link layer, we say data frames. Okay. In the textbook, it's not there, but I'm just telling all the words that people use, what do you call that? Is the technical words that are used. Again, in transport layer, it's called data segments. In network layer, it's known as data packets. In data link layer, MAC addressing layer, the data link layer, we call it data frames. Okay. Right. Can you all read this marking scheme answer also? Sorry? Adil is asking the link. It means you've been busy checking your phone. Kavish, you're busy checking your phone. Huh? How do you know otherwise? Okay, so let's keep moving, everybody. Adil is here. Adil, you heard him mentioning your name? Or I mentioned your name? Right, everybody, let's keep moving. Question number, can you guys read this here? Breaks the data into segments for transmission and reassembles the segments after data has been transmitted. Okay. There is a third answer also. Responsible for sending the data at the speed that the network is prepared for and checks the data for errors. Okay. This is somewhat similar to what we said over here, right? So here, depending if it's live streaming, it will immediately switch to UDP. If it's an internet phone call, it will switch to VoIP, depending on the requirements of the network. But if you all can just note down this answer, something I never told you all before. Breaks data into segments and then reassembles those segments at the destination. This is the duty of your transport layer. Okay, so then boys, girls, let's move away from here. The next one, most of you all scored your marks there. Okay, now? Isaga? An IP address can have an IP version 4 or an IP version 6 format. Okay, there is a mistake over there. It shouldn't be O, it should be AND, right? IP addresses are generally, if you're connected to the internet, it's generally both IP version 4 and IP version 6. So list 3 differences between the two. Anyone like to give a start here? Very good. That's a good start. IPv4, V6 IP version 6 uses 128 bits, while IP version 4 uses 32 bits. 32 bits. Something else you can talk about? IP version 6 doesn't have built-in supports. Or you can we say built-in? Correct. Built-in, you can say. IP version 6 has or supports built-in encryption, which IP version 6 does, IP version 4 does not. Something else? IP version 6 uses hexadecimal in its addressing. While IP version 4 uses the decimal or denary number system. Okay, let me just show you answers you all didn't think of. IP version 4 has 4 sets of digits, while IP version 6 has 8 sets of digits. IP version 4 is separated by dots or periods, and IP version 6 is separated by, everyone looking here, by colons. Okay, right, superb. Then guys, the website's domain name is www.hilmimega.com and the IP address is so and so. When someone wants to visit the website, they enter the domain name into their browser address bar. Describe how the connection is made to IP address so and so. So what happens, guys? When the domain name is entered, what does a web browser do? Everybody, you type your domain name and you press enter. What will your web browser do? Your web browser will check this domain name with the DNS server. Your web browser will refer, what do you call? Not refer, man. What will your web browser do? Your web browser will send this domain name to the DNS server looking for its IP address. Is it clear? Your web browser will send this domain name to your DNS server looking for its IP address. What will your DNS server do? No. Before that, your DNS server will have a database of domain names and IP addresses, right? Once your DNS server receives, what does DNS stand for? Domain name server. When the DNS server gets this request, your domain name server has a database of all the domain names and their respective IP addresses. So what will DNS do? DNS will go through its database looking for a matching IP address for the submitted domain name. And then it will return that IP address back to the web browser, and then the web browser can establish a connection with that particular IP address. Everyone okay with this? What if the IP address doesn't exist on the first domain that you checked? It'll do what we call a recursive query, right? Everyone know what's a recursive query? You will keep asking until somebody gives you an answer. You will be going from domain to you will be going from DNS somebody calls, it gets disconnected. Okay, so boys, girls, if none of the DNS servers have, you went from one level to another level, and none of them have your IP address, it means, what does it mean? You went to the highest level of DNS servers, and none of them have your IP address. None of them have an IP address for the domain that you're looking for. What does it mean? It means you have made a mistake in your domain name. You are requesting for a domain name that doesn't exist. Is it clear? But here, guys, do we need to talk about that recursive query and all that? We don't need to talk about it because they have said IP address exists. Isn't it? Question paper says the IP address exists. It means we don't need to talk about the other levels. So what do we say then? We can say the domain name will be sent to a DNS server. The DNS server will compare the domain name with its database of IP addresses. Once it finds a match, it will send that IP address back to the web browser. And then the web browser will be able to establish a connection with the respective server. Are we okay with this, everyone? Okay. So I'm not writing it down. Okay. The domain name server will reply with the respective IP address, and then your computer, your web browser will then establish a connection with the respective server. It knows the IP address now. Okay. Right. Then boys, girls, Hilmi uses a web hosting company to host and support his website. The company provides software tools to make both static and dynamic web pages. Okay, something that we covered. Give 3 differences between static and dynamic. 1 second. So that's the easiest one to start off with. Static web pages show the same content to every user, irrespective of who you are, irrespective of what you did previously on that web page, irrespective of what your interests are, you will see the same interest. You will see the same content, isn't it? Static web pages show the same content to every user, while dynamic web pages show what content? Personalized content. You see content that are related to your interest, related to your browsing history. Right, something else? Static web pages are developed using languages like JavaScript, HTML, and CSS, while dynamic web pages are developed using ASP, okay, Python, PHP, Python, PHP, okay. Any other difference? Okay, dynamic web pages will make use of cookies. I'm going to avoid it because it's somewhat similar to this. More complex to create. Okay, can we say these dynamic web pages are connected to a database? Dynamic web pages are connected to database. Static web pages are not connected to any database. Then guys, something else. Which one is loaded where? Dynamic web pages are executed on the server. The server executes and then sends content to your computer. Static web pages executed on the client's device itself. Okay, they executed on the client's device itself. Okay, which one can have a higher level of interactivity features like what do you call filter, searching? Dynamic web pages can have higher interactive features like sorting, filtering, searching, things like that. A static web page would not have. Okay, right. Everybody will move away from here. Gati has a blog. He writes articles about wildlife photography for his blog. He has a large following and thinks he can make money. Okay, so he's interested. He writes about wildlife photography. He has many people viewing his content. State 2 ways in which Gati could monetize his blog. Pay-per-click. Number 1 is he can do pay-per-click where he can display Google ads on his web page, and every time somebody clicks on those ads, he earns a very small commission. So since he's having a large following, when many people click on those ads, it could turn into a decent income. Something else? Sponsorship, or you can say sponsored content, where he can promote a certain camera, a certain lens, maybe a camera bag. Okay, he can promote certain products and he in return gets paid for doing it. One more. Yeah, I'm asking how. He can have a subscription model where if people want to read his articles without ads, they will have to pay him a monthly subscription. Or for example, certain articles he gives for free and other articles they'll have to pay a subscription to read it. Okay, no? Okay. These are ways he can monetize his blog. Then guys, our final question. Gati uses free cloud storage for his images. Explain one benefit and one drawback of using free cloud storage space. So Kavish, what do you think is your benefit of using cloud storage? You're getting 2 per mark. 2 per benefit and drawback. So cloud storage means you're storing your files on servers, right? Okay. And cloud means basically it's stored on the internet. On the internet means on servers. So benefit number 1, can I access it from any device? That's a major benefit for me, right? I can access my files from any device as long as it's connected to the internet. Is my storage scalable? Scalable means what? No. What did you say? You can increase it and decrease it as you wish. Okay? You're using 15 GB. You want 100 GB. You can increase it the next month. Next month, you realize 100 GB is too much. Can you reduce it the next month? You can. It's scalable. You can increase it and decrease it as per your wish. You can access it from any device, any location. Okay? Do you have to worry about setting it up and configuring it and maintaining servers? And do you have to worry about all that? You don't have to worry about all that. Okay? These are all problems for the cloud storage provider to deal with. Okay? What are your drawbacks though? You need a proper internet connection. If internet is not available, you are not going to be able to access your files. Okay? Any other problem? Are you in control of its security? Do you get to decide how they back up data, how they encrypt it? You don't. You just have belief that they will take care of your data. Agree with me, right? So you can say no control over security. Then guys, when you use this over 5-6 years, you might realize, when you use it over a long period, you will realize your subscription costs have, what do you call, when you add up your subscription costs, it might total up to you buying your own storage device. Is it clear? Okay, you can say on the long run, paying a monthly subscription cost could be could be expensive. That's not the best answer though. Okay, anything else? Nothing else? Let me see the marking scheme because nothing is coming to my mind also. Everybody look at the drawback. So yeah, limited control over security. There may be limitations such as bandwidth, storage time. Okay, then requires internet. We said these. Everybody okay with this? So then boys, girls, we are done with our exam correction as well. Okay, everybody? And boys, girls, everyone, we are going to start topic 4, even though today is our last week of the year. Okay, I'm still going to start it. Okay, because it's a chapter that will take some time. You have diagrams to draw. Okay, and everybody, topic 4 is only one part. Okay, topic 4 is only one part. This is the entire topic 4, which means how many topics remaining after this? 1, 2. How many topics? 2 topics, right? We have 6 topics, isn't it? So after this, we have 2 more topics. In the next topic, guys, you will be learning a new language, SQL. Okay, structured query language. Like I told you guys at the beginning, remember day 1, I told you, AS is very challenging. It's like, you know, after every chapter, the examiner is making life harder for you. Okay, but A2 is a lot more manageable. Okay, so guys, I also explained to you all don't need to score full marks. Okay, you all can make mistakes. Okay, you all can still end up with a very good grade. You all can even end up with 100. We spoke about it, right? Guys, when you score 100 for both the units, automatically you all become eligible for world prize. World prize means all 4 units you got 100. Is it clear? In your first sitting, okay? So target that 100, that makes you all eligible for a world prize. And I hope you all remember I told you all to score 100 doesn't mean you all have to have a perfect paper. I even told you all can even leave an essay question and still end up with a 100. Those possibilities are there. Okay. So everybody, topic 4, let's start. Students online, you all don't have it, so I'm going to send it to you all. Topic 4. Guys, girls, everybody, if you all can have a writing book, please maintain a writing book. Okay, we have notes to take down. Now today, guys, there are a couple of diagrams I need you all to draw with me. Okay, so you all need to have a a pencil, an eraser, a writing book with you. Okay. Then boys, girls, shall we have a look at IT systems? Right, boys, girls. Can you all read the second paragraph on page 1? The second paragraph on page 1, I have made some text bold and all that. Can you all read it? In this topic, you will learn how to break IT systems into smaller parts. Okay, why are we breaking into smaller parts? So it becomes easier for us to understand how the system works. When I say A-level IT, it becomes difficult for me to explain what is A-level IT all about. But it becomes a little easy if I can break it down for you all. If I tell you, what is A-level IT, there are two main parts. That is AS level and A2 level. In AS level, I break it down further. There are 2 units. In A2 level, there are 2 units. As I keep breaking it down into smaller and smaller parts, it becomes easier for me to explain it to you all. Also, it becomes easier for you all to understand, especially when you all are studying. When I say study IT, you do not know where to start. But when I say, there are only 6 topics in Unit 1. There are only 5 topics in Unit 2. Spend so much of time on topic 1. When I break it into smaller pieces, it becomes easier for you to grasp. Isn't it? Similarly, when it comes to IT systems, we try to break down IT systems into smaller parts. So it becomes easier to explain. Also, for the person who's trying to understand it, it becomes easier for them to understand. Everyone okay with this? Okay? All right. So guys, can you all read it? You will find out how data moves through an IT system and how to show this movement using some diagrams. Okay, how does an IT system work? You all are going to use 2 diagrams to show it. A data flow diagram and another one called flow chart. Okay, right. So then guys, can you all read the last one? You will also learn how to represent an IT system using a flow chart, data flow diagram, flow chart, and how to judge whether an IT system is suitable for a specific purpose. Okay, so interesting chapter. The part I don't like is this drawing part is what I don't like. Okay, sometimes the drawing goes to more than 1 page. It gets quite messy here. Okay, right. And guys, you all need to understand when it comes to drawing diagrams, 2 people will not have the same diagram. Okay, the way I draw a diagram and the way you draw a diagram in the exam could be different. So normally the examiner in the marking scheme, he'll give points. Have they shown this in the diagram? Have they shown that in the diagram? Is there a connection between this source and this process? He gives in point form. If that's there, give 1 mark. Is it clear? So your diagram, my diagram could be different. Okay, but it should be able to, tell the same story. You get it? Your diagram and my diagram visually could be different, but the story produced by both diagrams should be the same. Are we good? Right. Everybody, can we all come down to page number, Page number 4. The main components of an IT system. Okay. So everybody, when it comes to an IT system also, to make it easier for you all to understand, we are going to break it down into 4 main parts. What are the 4 main parts, guys? Number 1 is the hardware. What physical equipment is this system going to use? Number 2 is the software. What programs is it going to use? Number 3, what processors is it going to use? How is the hardware and software and people going to work? That is processors. And number 4 is people who will be using this system. Okay. So everybody, can you all read that example I have given you all below? An example of an IT system is a check-in system at an airport. So everybody, when you go into an airport, before you board your flight, you have to deal with a counter like this. I'm sure many of you all would have seen it. In an airport, you have a system called check-in, where you basically check into your flight. This is where they give you your ticket. This is where they label your luggage. Everybody okay with this? So you come over here and then you show the soft copy of your ticket. Okay, you show them the email of your ticket, or you show them a soft copy. Then over here they process your ticket, they print the ticket, they give you your, we don't call it ticket, we call it boarding pass. They print your boarding pass, they give you a boarding pass. And then over here, guys, can you all see these sides? These are where you put your luggage on. So you put your luggage here and then it goes all the way to the plane. Not directly to the plane, it goes somewhere, gets unloaded, they load it onto another truck or something, and they take it to the plane. But basically, when they put your luggage over here, there is a scale over here. The scale weighs the weight of your luggage. Then automatically there's a printer that will print the tags for your luggage. So whoever, the operator here, will remove that and then put the sticker around your luggage, send your luggage in. There's a whole system happening over here. Okay, there's a massive system happening over here. For me to explain it to you and for you guys to understand, it's quite complex. But I can make it easier for you all by breaking it down into many parts. If I break this system into many parts, then it becomes a little easier for you all to understand, because there are so many things happening in this system. Creating of the ticket, weighing of the luggage, okay, checking whether your visa is valid. So many things happening over here. So everybody come down. Don't come down. Can you all read the meaning of the 4 parts? Because I verbally told it to you all now. So hardware is all the physical parts. Software is the programs, okay, the interface. Okay, the buttons, the drop-down menus, all that. Then processors are the steps, actions, how does it work? And then people are the staff who use it, the customers who deal with it. Everybody who use it are people. So everyone, in the next page, we have a table talking about the airport check-in system. Okay, before you board your flight, you have to go and check in. Okay, you have to get your boarding pass. So how does that system work? In terms of these four components. In terms of these four components, how does it work? So everybody come down now. So number one, guys, we have to talk about the hardware component of the check-in system. So can everyone see the examples of hardware components? So number one, guys, we would have a electric scale. So everybody normally under this belt, so this is rolling, now this keeps moving to send your luggage behind. Underneath this, there'll be a weight scale to weigh the weight of your luggage. And then over here on this table over here, guys, how do I show it to you all? Can you all see there's a small LED screen here? Can see or can't see? Can you all see there's a small screen over here? Like this screen over here will show you the weight of your luggage. So you know whether you have gone overweight or whether you are within the weight range. Okay, right. Next, what do we have? A device to scan a person's boarding pass. Everyone, which device do you think we're talking about? A barcode scanner, right? Most probably it will be a barcode scanner. Okay, so on your email you have the flight, what do you call it? You have booked your flight details on your email. So what do? They just scan that, and then on the operator's computer all the details appear. Your name, what country you're flying to, okay, whether your visa is processed or not, everything comes on the screen. A computer to process the data. Everyone saw that now? So over here the computer is here that they will be using to process your data. Another hardware, a keyboard. Okay, everybody? A display screen to allow a person to see their check-in data. A speaker to play any notification sounds. Okay? A printer to print out any labels. Are we all okay with this? You have a printer to print out any labels that are needed to attach to a person's luggage. Then, guys, these are examples of hardware equipment at a check-in counter. Now read the software. So number one, there would be a user interface that would allow the staff to process your data. They can see forms and buttons and icons and things like that. Okay, an operating system, a database, utility software. Okay, then guys, there will be processors. How does the system, how does hardware, software and people, how do they all work with each other? So everybody, when you come to processors, for example, there will be different processors. Is it clear? So for example, they'll tell you one luggage at a time. Put your luggage and step a little that side. Because there are certain tricks you can play when it comes to luggage. So they will tell you, they'll tell you, put your luggage and you move behind. Because sometimes you know what some people do? They put the luggage. Now she can't see the person's leg, right? So what does he do? He lifts the luggage slightly up. So then the weight is not accurate. Okay? So normally the rule is they tell you put your luggage and tell you to step behind. Okay? Because they can't see your feet. Okay? So you could be lifting the luggage while it's on the scale. So they would tell you to step behind. Or for example, sometimes they'll have an order. First give us your passport. Okay? Then show us your flight details. Then put your luggage. They'll have a certain order that they deal with you in. These are all examples of processors. How do they do it? Okay, can you guys read it now? Putting luggage on the scale, scanning your boarding pass, entering a person's data in the system. Did I show you all this? There was a stand-up comedian. He talks about airport check-in. I didn't show it to you all, right? Okay, I'll show that video to you all. Then maybe you all might, Retrieving a person's data from the database, waiting for a luggage label to print. Earlier, guys, now recently when I went, guys, earlier at check-in, they don't care whether you have visa or not. That's not their concern. All they care about is whether your luggage is under the correct weight. If it is overweight, have you paid for it? Is it clear? And they also care about the content of your luggage because the plane is theirs now. So Sri Lanka Airlines will have operators. Those operators, all they care about is, the weight of your luggage, your boarding pass. Is it clear? whether you have any, what do you call, items that you're not supposed to take on the plane. That's what they check on. But now recently, they have also been told to check whether the customer has a valid visa to go to that whatever country he's flying to. Earlier, they used to not check all this. I don't know why they're doing it now, maybe new rules. Now, another process that the operator has to do is check whether the customer has a valid visa. If they don't have a valid visa, at that point itself, block them from going any further into the airport. Earlier, visa and all was checked somewhere else. Okay, but now for some reason, at the check-in operator, they're checking your visa also. Another process. Okay? You guys get what I'm saying here? Okay? Then guys, can you all see people? These are people who will be dealing with the system. So obviously customers, people who are checking in for a flight. Then people, employees. Okay? Right. Everybody, can we keep reading the next part of it? So hardware, software, people, processors. Okay? Right. Now can you all read the next heading, the next subheading, everybody? Decomposing a system into subsystems. Basically breaking one system into many small systems. Why are we doing this, guys? Louder? To make it easier to understand, right? Everybody, to make it easier to understand. Okay, just like how I told you all about your A-level IT. When you say A-level IT, so many things to consider. But if you start breaking it down into smaller parts, okay, it becomes easier for the person to understand what the subject is all about. Okay, all right, can you guys read it? Some IT systems can be large, and it is helpful to be able to break them down into smaller parts and then understand each part. Breaking an IT system down into smaller parts is what we call decomposition of the system or decomposing a system. Okay, you're breaking this complex system into smaller, understandable parts. A smaller system of a larger system is often called a subsystem. Okay, if you look at the example of the airport check-in system, this could be broken down into two smaller subsystems. For example, subsystem 1 is to deal with weighing of your luggage. Subsystem number 2 could be scanning your board pass to check you into the flight. Everybody okay with this? Nothing complex here now? So far, so good. Right. Can you all read this? I took this from your textbook and I thought I should attempt it with you all. Think about an IT system that is familiar to you. You could choose one of your own, but if you cannot think of any, here are a few ideas. Think of a school library IT system. Think about an elevator. Think about a supermarket self-checkout. Break down the IT system into 4 component parts as in table 4.1. Okay? Table 4.1 I haven't given. I gave you all, means also on in your paper. It's there. Hardware, software, processors, people. So shall we pick up a system and shall we do it? What system shall we take? Self-checkout. Okay, so I'll do it on my screen itself. Okay, give me a second, please. So I'll do it on my screen itself, everybody. Anybody else want to try any other systems? So I'll put the heading over here, decomposing a system. Okay, decomposing an IT system. Okay, all right. So we said what? Any examples in mind? One second. So in terms of hardware, So everyone, let's take an image also to make it a bit easier for us to understand what we are dealing with. So shall I say over here, Keel's self-checkout. We'll see if we can have an image that would help us. Here you go. This image looks pretty good. Yep, I think this should do. 1 second, please. All right. So in terms of hardware, guys, in terms of hardware, like he said, a touch screen maybe, or a computer system. We'll go with touch screen. Something else you see there? Scanner. Which scanner are you talking about? Barcode scanner. All right. Something else you see over there? Card reader you definitely need. You need a card reader. Something else you need? A printer. You need a printer. Something else you need? Sorry? Speaker. Okay, speaker. I think none of you all have used this checkout, isn't it? If you all have used it already, immediately told me this answer. Anyone here has used the self-checkout? You have used it? So, how shall I ask you telling the answer? Sorry? How can I ask you without telling the answer? These are my items. These are my items. I scan it. And until I do something, I can't scan the next item until I keep it over here. So for example, I have 2 items to buy. I scan the first item. It got recorded in the computer. Until I keep it on this side, I can't enter this item. How does the computer know I have kept this item on this side? Sense of? Not motion. No. What do you all think? So I have 2 items over here. I scan this and then I have to keep it on the right hand side. So you start from the left and bring your items to the right. So at the left also, you have to first place all your items on the left. And then one by one, start moving your items to the right. And then at the end, it knows whether everything that you added there has been billed or not. Because it will be checking what? It will be checking the weight. The weight of what you added versus the weight of items that you checked out with. Were they the same? If they were the same, it knows it has billed, what do you call? It has billed everything that you took. Everyone okay with this? Before you start billing, everything has to be kept on that area. This area over here. Here, can you all see? There is 2 spaces here. Here you keep all your items. Everyone over here, you keep all your items. And then after you finish it, you keep it on the right hand side. Okay. So until you keep your item on the right hand side on this, there's another scale over here. Any other images to show you all that? Okay. So until you do that, guys, it doesn't allow you to enter the next item. You get it? Until you do that, you can't enter the next item. Okay. So weighing scale would also be there. Okay. Weighing scale would also be there. Right. Then boys, girls, in terms of software, what would you say? In terms of software, I'll start with the easiest one. There has to be a user interface, right? There has to definitely be a user interface. Next. Next, guys, now here they only accept card payments. As soon as you make your card payment, the system is instructed to print the bill. So isn't there a program between card payment and the payment system? Isn't it? Okay. Program to accept card payment. Anything else? How does from where is product, the name of the product has to be connected to a what? Database. There has to be a database. Okay, right. Then in terms of people, who do you think the people would be? Number 1, most obvious would be your customers. Then if you run into a problem, who do you call? Sometimes you run into a problem, you are adding something, you added the wrong item, wrong price recorded, discount wasn't given. Who do you call normally? Manager. Manager. Sometimes maybe a cashier will come to assist you. Or sometimes, guys, if all the counters are full, the manager will tell the cashier, you start making bills from the self-checkout now. You get it? Okay, so then maybe cashier also will come into play. All right, what are your processes? Why am I not showing you all this? Everybody, what are your, oh, guys online, I'm sorry, I haven't been seeing your messages. Esandu, very nice, rank scale, all that. Yes, Akash, I didn't see, I was zoomed in now. Processes, what shall we say? Okay, so only card payment now, accepting of card payment. Okay, accepting card payment. Next, weighing of goods. Weighing of goods. Generating of. Generating what, guys? Generating bill. Generating bill. I don't see anyone noting it down. Guys, this is an activity for you all, which I am doing. You all should also be working with me. I thought you all will be writing and telling me. Generating bill. Okay. Then maybe awarding loyalty points. Okay. Awarding loyalty points. Okay, decomposing an IT system. Okay. So when you break it down this way, it becomes a little easier to understand how a supermarket self-checkout works. Okay. Right. Boys, girls, everyone, I'm going to move away from here. Now, when it comes to decomposing a system also, the way you decompose the points that you identify under processors and the points that I identify under processors could be different. The wording that you use, the wording that I use could be different. Okay. But as long as they both paint the same picture, the same story, the examiner will be okay with accepting it. Okay. So I might say generating bill, you might write printing of bill. Or you might say, what do you call, SMSing of e-bill. You might say something like that. They both, pretty much say the same thing. Right. So everybody, so in the marking scheme, they would normally mention, did the student mention about the bill? Then give 1 mark. Did they mention about, what do you call, card payments? Give 1 mark. Right. Then everybody, guys, girls, let's move on to Now, drawing diagrams to explain how a system works. Drawing a diagram to represent how an IT system is working. Are we all okay with this? So everybody, we learn decomposing now. Now we are going to be looking at diagrams that we can draw. Okay. Okay, diagrams that can be drawn to represent an IT system. Right. Everybody, can you all come down to the next part? Data flow. Representing IT systems as a diagram. It can be difficult to understand all the actions in processors of a large system. Okay, including where and how all the data is to be used and transmitted around the system. However, it is important for an organization to know this information, isn't it? It can be difficult to understand, but an organization must know how data flows in the system. There are two types of diagrams that can be used to improve our understanding of an IT system. What are the two? Data flow diagrams and flowcharts. Okay. So everybody, can we come down to data flow diagram, everybody? Come to data flow diagram. What does it tell us? It visually, okay, you can see how data moves through a system. Who gives it? How is it processed? Or how is it processed? What process happens to it? Where is it stored? You get to see that. Can you guys see it? How the data is entered into the system. Through which input does the data get into the system? Then what process takes place to that data? Okay. Then where is it being transmitted to and from? Okay. Where is it being stored within the system? This data that was input, this barcode number that you just gave, what is it used for? Where is it stored? Okay. And how the data leaves the system. So you give the barcode number, in return, what do you get? The product name and product price, right? Isn't it? You give a barcode number, in return, what do you get? You get the data in return as product name and product price. Or you give the barcode, in return, what do you get? You get a bill of all the products that you purchased. Okay, sounds confusing. Bear with me. It will make sense to you all. Table 4.2 contains a set of symbols that you will use to create a data flow diagram. Everybody, when it comes to the symbols, non-negotiable. You can't use your own symbols the way you want. They have given you symbols. That's why I have put the textbook table itself over here. You have to use these symbols. Okay, everybody, I want you all to draw these again in your writing book. Okay, not now, in a few seconds. So everybody, the oval shaped symbol represents a what? Represents a source. Something that is entering data into the system or something that is receiving data from the system. What do we call it? You can call it a source. Okay, you can call it a source, or you can call it an entity. Everybody okay with this? We'll be drawing it. Okay. Can you all read the textbook purpose? This symbol is used to show a data source, something that's going to input data or receive an output. This is a place where data is input into the system or output from the system. Okay, so for example, in a supermarket checkout, the customer can be a source. The barcode scanner could be a source. Okay. And then guys, sometimes your diagrams will be very big. You may need to draw the same source again somewhere else. So then guys, duplicate source means what do we do? Oval shape with a line across it. Not across it, on the side of it. Can you all read the purpose? Why do we have it? Because sometimes our diagrams will be very big. We may not be able to connect with the original source. So then we draw the same source twice. And then not to confuse the reader, we show what is duplicating. Then guys, can you all see the symbol for a process? For a process generating a bill, weighing this, weighing an item. Okay. Processors are drawn inside that shape. I don't know what you call that shape. Then everybody, data storage points. Can you all see the shape? Where data will be stored, that will be drawn using, you can see the shape over here, right? This is a shape for a data storage. Okay. And then you have arrows to show the direction that the data is flowing from source to process, from process to storage, from storage back to source, back to process to source. There are certain rules also. I'll give you all those rules a little later. Okay, right now, if I give you all those rules, it won't make sense because you have never drawn a data flow diagram. After drawing a couple of data flow diagrams, I'll show you all those rules, then the rules will make sense. Okay, everybody, can we redraw these shapes on your writing book? Just for practice purpose, okay? It's anyway there in your tute. Just for practice purpose, we are drawing it again. So everybody, can you just put down a heading, data flow diagram symbols? Data flow diagram symbols. Okay. So everybody, oval shape represents source. It could be input or output. Okay, your source could be giving input or it could be receiving an output. Okay. Duplicate source. Normally it is used when you have a large diagram. Okay. Then we have process. Okay. Data storage. So guys, the diagram name itself tells you the purpose of it. Data flow shows how data flows in an IT system. That's all it does. How does data flow? When you enter a barcode, where does that barcode number go? Okay. Because of that barcode number, what is the output? This is data flow diagram. How does it go? When does it go? You know, all those happens in a flow chart. Okay, everyone. All together. Shall we look at an example, guys? Again, the airport check-in system, boys. Shall we have a look again at the airport check-in system? You'll have your pencils with you all to draw on the tute itself. Not to draw, just to, you know, understand it. Guys, okay, everybody, can you all read with me now? We can try creating a data flow diagram for the airport check-in system we looked at earlier in the topic. So guys, this is from your textbook. Your textbook had the same example. I took it. Okay, we need to break the system down into the following parts. So when drawing a data flow diagram, guys, number one is what? Break down the scenario. Now we're talking about a airport check-in system now. So whatever scenario the examiner gives you, break it down first into three parts. What are the data sources? What are the processors? And what are the data storage points? Okay, this is all brand new for you all. So you all are going to take some time to grasp it. Okay, but after some time you all will be okay with these rules. Okay, right, now let's move down. The data sources for a airport check-in system, what are they? we have identified the barcode scanner, the weighing scale, and the customer. Data will be received or given by the barcode scanner, the weighing scale, or the customer. What are the processes that should happen in a airport check-in system? Scanning the barcode on the boarding pass, weighing the luggage of every customer, and printing a label for the luggage of every customer. These are the processes we have identified. Where is the data going to be stored? We will have a database of all customers who have checked in for their flight. Then we will have another database of all the luggage information. Okay? Pretty straightforward, right? Right. Can you all read the next one now? Now let's look at the data flow diagram. Everybody, when drawing a data flow diagram, normally my practice is not textbook practice, not recommended practice. I like to first draw the processors. When I draw the processors first, it becomes easy for me to understand what are the sources and the data storage points. Is it clear? So a habit I have is, you will see when we do exam questions, I first draw the processors. Then I start identifying the sources and the data storage points. So can you guys also look at the processors first? Process number 1 is processing the barcode data. Okay, processing the barcode, meaning processing the customer's ticket data. Okay, so where do we get the ticket data from? Everybody, where do we get the ticket data from? From the barcode scanner. Everybody okay with this? We get the data from the barcode scanner. Okay, and then where is it stored? It's stored in customer flights data storage. Am I making sense to you all? Let me take a proper pen and draw. Everyone, look at the processing of barcode data. Okay, now in the barcode, in receiving barcode data, what data are we going to receive? We're going to receive it from where? We're going to receive it from the barcode scanner. What are we going to receive? We're going to receive barcode data. When you say barcode data, we're talking about the customer's ticket data, the ticket number maybe. Okay, that data will be taken and stored where? It will be stored in the customer flights database. Then guys, can you all see from process 1, the customer data is going to process 2. The same customer data is now going to process 2 in order to process their luggage. The same data is going down to the second process to process their luggage. In processing their luggage, guys, in that process, we get data from the weighing scale. What data do we get from the weighing scale? The reading of the weight. Understand that? In processing their luggage, we get input from the weighing scale. That same data, where do we go and store it in? We go and store it in our database called luggage details. What data do we store in luggage details? The customer's luggage details. The customer's luggage details are stored in luggage details. Okay? That same data, can you all see over here? That same data, the customer's details and the luggage details are taken down for what process? For printing the luggage label. And then guys, we have an output which is given to the customer. Can you all see? The source is the customer and output is given to the customer. What is the output, guys? The ticket is given to the customer. I don't expect all of you all to fully understand this, okay? And the way you guys would draw it, the way I would draw it, and the way the textbook has drawn it could be very different. But what is important? We should all give the same idea, story, picture. Is it clear? Our diagrams could be different, but at the end of it, we should all be giving the same story, the same picture. Are we okay with this? Okay? Right. Then boys, girls, I do understand it's going to be a bit difficult for you all. But we'll talk about it, take a break, come back and draw it. Okay, so what do you all think about this? Can you all read this rule first? Okay, everybody, ignore number 2 because level 1 is not there for you all. I just showed you all. In A2 level, you all will have level 1, level 2. Everybody, before you start, guys, read the scenario carefully. Okay, identify who sends data, who receives data, and what data is involved. Okay, you all don't have level 1 and level 2 diagrams. You all have only level 0. So you all don't have to worry about it. Then guys, just like the textbook said, identify hardware, what do you call? Identify your processors, your data storage points, and your sources. Okay, everyone, we are going to follow these rules now. Identify who are the external entities, your sources basically. Identify what are the processors. Identify where your data is going to be stored. Identify where the data is going to flow. In which direction is it going to flow? Sounds confusing. We'll start doing an example now. Can everyone read this example over here? Where is it? Think about the IT system that you broke down into 4 components in activity 1. Decompose the system that you choose into as many subsystems as you can think of. Share your subsystem with a partner. Would they have chosen the same? Not this one. I think I'm the wrong one. There was another activity I wanted to do with you all. Where's my note? Everybody, shall we just put down the heading? You all draw the final diagram at the end, okay? We'll put down the heading. What shall we say? What shall we say? Self-checkout. Supermarket self-checkout. Supermarket self-checkout. Okay. So everybody, what were the 3 rules now? We first identify what? Identify the processors. Identify processors. Number 2, what were we doing? Identify the sources. And number 3, identify where the data is going to be stored. Identify data storage points. Identify data storage points. Are we all okay with this? Okay, you all can take a break with that then. And everybody will be back at 1:30. Note down these 3 rules, and then based on these 3 rules, when you all come back, we'll start writing them. Guys, girls, all of you all, we're going to continue, guys. There was a small delay because everybody is getting their report cards now. Okay, right, everyone. Where were we? We gave you all a scenario. Everyone, this was the scenario over here. Supermarket self-checkout. Let's think about Keels, and Keels is the only example I can give you right now. So let's identify the processors. Let's keep it simple. Okay, no need to think about the weighing and is the item there, not there. No need. Okay, so everybody, number 1, what would you tell me? In terms of number 1, what are the processors you can think of? As I know, when I walk into Keels, the first question when I use a self-checkout, first question is loyalty number, right? Verifying loyalty number. Now, then you all tell me, verifying loyalty number. Verifying loyalty number. Then next is, and then is next is what? Pretty much entering your items you purchased, right? Okay. Recording purchased items. Recording purchased items. And then finally, guys, what do we have? Generating of bill. Recording purchased items. Generating bill. We can go on to talk about the verification of card payment, but shall we avoid that? Okay, we'll keep the diagram simple since it's our first diagram. We are purposely avoiding the card payment part. Verifying your card payment, we are purposely avoiding it. Generating bill. Okay, I'll just say verifying card payment. Verifying card payment, and I'll purposely put not included. I'm purposely not including it to keep the diagram simple. Then guys, your sources could be what? So definitely customer is going to be a source. Okay, you're definitely going to have a customer. Another source would be, girls, all of you, we are now filling up what we spoke about. Customer is one. It's a bit weird. Barcode scanner. Barcode scanner. Anything else? Customer, barcode scanner, anything else? Monitor, for which? Loyalty points, no? Touch screen. Touch screen. Very nice. I cannot think of any other data sources. If anything comes up, I'll let you all know. Number 3, your data storage points. Customer database for sure. Okay, customer database. We definitely need a customer database. And then we also, so customer database is to record their loyalty points. And the billing details, shall we have billing database or customer purchasing database or order database? So I'll say billing database, billing details, billing details. So everybody, we'll start off by drawing the processors. Okay, I would recommend you all take a new page because you all might definitely run out of space. I'm using a tab, I can always erase. Okay, we're going to draw a data flow diagram. What is our objective behind the DFD? We are trying to show the flow of data. How is data flowing? Okay, so everybody, I told you all we'll start drawing with the processor. It's a lot easier when you can identify the processors first. Okay, so everybody, let's draw our process. So shall we start off with the process of verifying loyalty number? That's the first thing Keels asks, you know. So process number 1 that Keels self-checkout does with you is verifying your loyalty number. Process number 2 is recording what you have purchased, and process number 3 is giving you a bill. Okay, girls, you all not there. We said we are purposely ignoring the card payment part. Okay, we are purposely, because our first time drawing it, we are purposely avoiding this. Okay, so everybody, process number, everyone wrote it now. Process number 1, guys. I do not know how. I would recommend you all take a new page. Right in the middle, I'll draw process 1. Process number 1, verifying loyalty. Verifying loyalty. I know they all can read, everybody. It's saying verifying loyalty. Who is going to enter this data, or rather, what is the source that's going to give this input? The customer, or shall I put the touchscreen? Because in a self-checkout, we have a touchscreen there that we type it into, right? Or we can even say customer, right? In a self-checkout, there is no, because if you go to the physical cashier only, there is a separate screen for you to enter your loyalty number, isn't it? In the self-checkout, you enter it into the computer itself, isn't it? So we'll say customer itself. We'll directly say customer itself. Who is the source for this? The customer. The customer will enter what? The customer will enter loyalty number. Loyalty number. And where will this number go to? This number will then be stored in the customer database. So and so came and made a purchase. Loyalty number. Okay, so now we have a data store now. We have a data store here, which is our customer database. My line is a bit of a problem. royalty number. Then guys, our second process is, everybody, our second process is what? Record the purchases, right? Items purchased. Recording items purchased. Our second process is recording items purchased. Number 2, what do we have? Recording items purchased. Where do we get this data from? This data is all coming from our barcode reader. Barcode scanner. So here what do we have? Product ID. And then guys, where is it being stored? We are going to have a database to store order details. Order details are going to be stored over there. Order details. Everybody over here. Everybody over here, what do we have? We will have a line from here. Product details. Product details. Okay. Then guys, process number 3 we identified as generating of the bill, right? Printing of the bill. Generating bill is our third process. Okay, generating bill. Generating bill. So guys, generating of bill is going to come from where? Zoom in a bit. Much I can go into. In order to generate the bill, it needs to be continuously getting data from where? Between the process, we could, you're saying from recording items purchased, we take the data to generating bill. I thought of taking the generating bill from the order details database. Everything is stored in the order because in multiple purchases, multiple products now, the customer is purchasing multiple products in a purchase. The customer is buying multiple products in a purchase. They're all being stored in order details. Then from the order details, it will give us the final list of items the customer has bought. Is it clear? The final list of items, we'll draw straight lines. Now I have realized I made a small mistake. Okay, the final list of items. Final list of items. Final list, or you can say bill, pretty much the bill. Calculated bill comes from here. Calculated bill. And then the output is given to whom? The bill will be given to, who is the bill given to? The customer. Okay, anything to tell me here? Sorry? Duplication, very good. So you will draw a line here to say, you know what? This is a duplicate source. But does anyone see any problem here? I just realized. Nobody sees any problem here? Very good. Sorry? Customer database, yes. Is not connected, right? Is not connected as in it should be connected to what? The billing, right? In the bill, you get the customer loyalty details, right? How many points they have earned so far, isn't it? So that needs to, I ran out of space. The customer database needs to be connected to which process? Into which process you need to connect it to? Generating of bill. When it comes to generating of bill, the customer, because in the bill you will mention how many points they have earned, isn't it? So this is a problem. Our diagram is going to be a bit messed up. So I will have to take a line like this, which is wrong. Not wrong, it's your diagram is not clear to understand. Okay, loyalty points. Loyalty points. You will calculate the bill. You will also mention the loyalty points, and then the customer is given the bill. Everybody okay with this? Now I want to show you all some rules that I would like you all to memorize. Okay. Okay, so everyone look here. Everyone look here. There are a couple of rules that I want you all to memorize. Textbook hasn't mentioned it, but you all should remember these rules when drawing DFTs, because DFTs can be quite confusing. And you might think, you know what, I can do certain things when in fact you are not allowed to do those. Okay, it violates the rules of data flow diagrams. Okay, Nitika done now? Girls over there? Okay, can you all read this rule here? So these are the shapes. You have to use these shapes. You can't use your shapes. Okay, processor should be verbs. You know what verbs are? Actions. It should be in action form. Verifying loyalty, recording items. Okay, you should use verbs. Okay, one direction per data flow. Every arrow can only go in one direction. Okay, avoid crossing lines. It's not wrong, but avoid it. Otherwise, reading a diagram is going to be very difficult. That's why, guys, I took this around. I took it around. Okay, but still it's a bit complex. Okay, but do not take a cross lines. You know what a cross lines means, right? Like this, don't draw. Okay, avoid it. Right. Then, boys, girls, some rules, things that you mustn't do. Okay, common rules. External entity to external entity. An entity and entity cannot have direct flows. Everyone okay with this? Two sources cannot have direct flows. Customer and barcode can never have arrows. Okay, everybody. Flows have to, a flow between a source and a data storage has to always go through a process. Can you remember this? Or, for example, if two sources are communicating, they have to go through a process. Okay, for example, if you are writing, verifying barcode, customer is, cashier is typing the barcode, system is verifying it, then where is it being stored? It's being stored in the order database. Okay, but directly cashier to data source, you can't. Okay, everyone understands this, right? Entity to entity cannot be connected. Data store to data store cannot be connected. Entity to data store cannot be connected. There should always be a process in between. Can everyone remember this now? Okay, a process, a source and a source cannot be connected except through a process. A source and an entity cannot be connected except through a process. Are we all okay with this? Keep that in mind, okay? And then, guys, can you all read this? Don't need to read 12 because you all are only dealing with level 0. You all are not doing level 1. Maybe in A2 you all might have. Now, can you guys read 13? Data flow diagrams show what data flows, not when, no, how. When, no, how, we look at flow charts. Data flow diagrams, guys, you only show how the data is flowing. You don't put any rules into it. Only if this happens, this should be the output. Else, no, we don't do all that in data flow diagram. The data flow diagram, we only show the flow of data. Okay? Everyone okay with this? Remember this, okay? Right. Ask yourself this, guys. Does every process have at least one input and one output? Okay? And then does the diagram match the scenario exactly or accurately? Okay? Right. Then, boys, girls, shall we move away from here? Where are we? We are. All right. Can we all have a look at the next one? Flow charts. Okay, this is a bit more complex, but a bit easier to draw than data flow diagrams. Even though they are a bit more complex, drawing them is a bit easier. Okay, all right. Can you guys read the bold words? A flow chart visually shows you the steps and decisions and decision points in a process within a system. It could involve multiple processes within a system. Everybody okay with this? Can you all see what a flow chart shows you all? The inputs that come into the system, the outputs that are produced from the system, actions that occur within the process, decisions that are taken, the sequence, what happens first, what happens second. Okay, the sequence is also shown. Okay, guys. So can we draw these symbols, guys? Can we first understand them? Everybody, the first symbol, oval shape again. What do we call it? It's the terminator. Every flow chart has a start. Every flow chart has a start, but not every flow chart has an end. There are some flow charts, they run again and again. What do we call that? Loop. Some flow charts are on a loop. There is no end. They keep running. Okay, so every flow chart will have a start, but not every flow chart will have an end. Read the next one. The next one is an input or output. What do we call that shape? We call that shape a parallelogram. A parallelogram is drawn to represent input or output. Read the next one. A rectangle is used to represent a process. Something is happening, adding, generating, okay, calculating. Then decisions. If, else, if it's more than this should be the output. We use a rhombus or a diamond. Okay. Then, guys, sometimes in a system there are other processes happening. So those processes, sub-processes, we represent using this shape. Okay, we call them sub-processes. I'll give you all examples later on. Okay, right. Before I go, guys, can we draw these symbols? And then next year we'll do examples for flowcharts. Okay, so everybody, let's just draw this. We have a few minutes remaining now. Symbols of a flowchart. Symbols of a flowchart. So what do we draw, guys? The terminator, start and stop, or start and end. Terminator, start or stop is represented here. Then we have inputs represented using a parallelogram. Not only input, input or output. Enter number, display something, use this symbol. Then, guys, process. Okay. This represents a process. This represents a decision. If, else. Okay. So, for example, verify password. It's a sub process. How it works? is defined somewhere else. Everybody, tomorrow's practical class, unit 2 class, we continue with JavaScript, our final part in JavaScript. Okay, events. Okay, until I teach you all that, I can't do past papers with you.